Hello, my dear students. Welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe this channel and press the bell icon to get the regular updates of the upcoming lectures. My dear students, today we are going to find the stability order of O2 molecule with a 1 unit positive charge and the O2 molecule with a 1 unit negative charge by evaluating their bond orders. In the previous lecture, I have told you that higher the bond order, higher will be the stability, higher will be the bond dissociation energy, and lesser will be the bond length. So let's move to the screen. So that's the screen on which I have already made the molecular orbital diagrams. So now let's evaluate the bond order for O2, O2, 1 positive and the O2 with the 1 negative charges. So first of all, I'm talking about the O2 molecule. Let's talk about the O2 molecule. Now, what's the formula to evaluate the bond order? In the previous lecture, we have done that. Number of bonding electrons minus number of anti-bonding electrons divided by 2. So now, let's fill these molecular orbitals. Here I am taking first oxygen on the left hand side, and that's the second oxygen on the right hand side. What's the electronic configuration of oxygen? Its atomic number is 8, so its electronic configuration will be 1s2, 2s2 and the 2p4. So now let's fill the electrons in the atomic orbitals first. In 1s we got the 2 electrons, in 2s we got the 2 electrons, and in 2p we got the 4 electrons, and we have to fill the 4 electrons in 2p according to the Hund's rule. So that's the first electron, second electron, third electron and the fourth electron. Now same goes to the second oxygen. Its configuration is same, 1s2, 2s2 and a 2p4. So let's fill the electronic configuration, or we can say let's fill the atomic orbitals of the second oxygen. So that's the 1s2, 2s2 and we got the 2p4. So that means we are having 8 electrons on the left hand side and we are having 8 electrons in the right hand side. So that means we have to fill total of 16 electrons in the molecular orbitals. So we have to fill total of 16 electrons in the molecular orbitals, and the 16 electrons will belong to the O2 molecule. So let's fill these 16 electrons according to the Aufbau rule and the Hund's rule. Aufbau rule states that the electron will get filled in the molecular orbital with lesser energy, and then it will get filled in the molecular orbitals with the higher energies, and so on and so on. So that means out of 16 electrons, first 2 electrons will be in sigma 1s, 1, 2, then 3, 4, then 5, 6, then 7, 8, then 9, 10, then 11, 12, 13, 14, 15 and 16. So we have filled the molecular orbitals of O2 molecule with 16 electrons. So now let's evaluate its bond order. First of all, we have to count the number of bonding electrons. Number of bonding electrons. Now, bonding electrons are those which are present in bonding molecular orbitals. So let's count them. This is 2, then 2 plus 2, 4, then 5 and the 6, then 7, 8, 9 and the 10. So we get got total of 10 electrons in bonding molecular orbitals. So we got 10 electrons in bonding molecular orbitals. Now let's talk about the anti-bonding electrons. Number of anti-bonding electrons. Let's count them. Let me take a different color for it. Now, anti-bonding are the electrons that are present in molecular orbital with the star marked on it, because the molecular orbitals with star sign are anti-bonding molecular orbitals. So we got the first two, 3 and the 4, 5 and the 6. So we got 6 electrons in anti-bonding molecular orbitals. So I'm writing, we got 6 electrons in anti-bonding molecular orbitals. So now let's evaluate the bond order for O2 molecule. I'm writing bond order for O2 molecule. It came out to be, the number of bonding electrons are 10, number of anti-bonding electrons are 6, divided by 2, we got it to be 2. So the bond order of O2 molecule is 2. Now we got the bond order of O2. Now let's talk about the O2 molecule with a unit positive charge. So I'm taking different color. Now it's turn for the O2 positive molecule. So I'm deleting some things over here. Now, if we have to take the O2 positive molecule, that means we have to now fill 15 electrons instead of 16, because O2 positive stands for O2 molecule has lost one electron. So now we will be filling 15 electrons in O2 positive molecule. So for O2 positive molecule, so in this structure, these are the 16 electrons in the molecular orbitals. I'm going to delete one electron. Now we got 15 electrons in O2 positive molecule. Now for O2 positive molecule, let's evaluate the bond order. And for that, firstly I'm writing number of bonding electrons. Let me clear you one thing, that I have deleted the electron from the molecular orbital which have filled at the last, and it was pi star 2px and the pi star 2py. I have deleted an electron from pi star 2py because pi star 2py was the molecular orbital that was filled at the last in case of O2 molecule. So we have to now count the number of bonding electrons in O2 positive molecule. Here, let's count them. We got the first 2 electrons in bonding molecular orbital, then 3, 4, then 5, 6, then 7, 8, 9 and 10. So we got 10 electrons in bonding molecular orbitals. Which were the bonding molecular orbitals? Which was not having the star sign. So we got 10 electrons in bonding molecular orbitals. So I'm writing, we got 10 electrons in bonding molecular orbitals. Now let's talk about the number of anti-bonding electrons. So we have to now count the number of electrons that are present in anti-bonding molecular orbitals, and which were obviously the molecular orbitals which are having star sign on them are anti-bonding molecular orbitals. So now let's count the electrons in them. uh, Let me delete one thing for you. So now let's count the electrons present in anti-bonding molecular orbitals, the orbitals which are having star signs over them, right? So we got the first two electrons in sigma star 1s, then next two in sigma star 2s. We got the total 4, and we got at the last the fifth electron in pi star 2px. So we got the 5 electrons in anti-bonding molecular orbitals in case of O2 positive molecule. So its bond order will be, now let's evaluate the bond order for O2 positive molecule. We got it to be 10 minus 5 divided by 2. Let me rewrite it for you. The number of bonding electrons were 10 minus number of anti-bonding electrons were 5 divided by 2, and for O2 positive we got it to be 2.5. Now let's talk about the O2 negative molecule. O2 with a unit 1 negative charge molecule. In case of O2 negative molecule, we have to add one electron in molecular orbital, right? For that, let me redraw the molecular orbital configuration of only O2 molecule with a 0 charge. So in O2 molecule we were having total of 16 electrons and 1 electron in pi star 2p. Why I'm remarking it, sorry. Now in case of O2 molecule with a unit negative charge, we have to increase an electron. So that means in case of O2 negative molecule, we have to now fill 17 electrons instead of 16. So we are going to add one electron which will fill according to the energy order of molecular orbitals in pi star 2px according to the Hund's rule. So we got the third electron over here, and we got one extra, that is 17th electron in pi star 2px. So we got one electron extra in anti-bonding molecular orbital, that's pi star 2px. So let's recount the number of bonding electrons in O2 molecule with a unit negative charge. I'm writing number of bonding electrons, that is electrons which are present in bonding molecular orbitals, that is molecular orbitals which are not having star sign over them. So I'm counting. That's the first two electron in sigma 1s, that's the bonding molecular orbital. Then sigma 2s, we got the total of 4 now. Then 5, 6, then 7, 8, 9 and 10. We got the 10 electrons in bonding molecular orbitals. So I'm marking 10 over here. Now let's count the number of anti-bonding electrons in O2 negative molecule. So that means we have to now count the number of electrons which are present in anti-bonding molecular orbitals, that is molecular orbitals which are having star sign over them. So, firstly sigma star 1s, which is having 2 electrons, then sigma star 2s, then 2 electrons, we got total of 4 now. Then it's a turn of pi star 2px and pi star 2py, we got 3 more electrons in antibonding molecular orbitals. So we got total of 7 electrons. We got total of 7 electrons in anti-bonding molecular orbitals. So I'm marking 7 over here. So I'm writing bond order of O2 negative molecule. So number of bonding electrons are 10, number of anti-bonding electrons are 7, divided by 2, we got it to be 1.5. So now I am arranging the strength order of O2, O2 positive and the O2 with the negative charge according to the bond order. For O2 positive, for O2 positive we got the bond order of 2.5. For O2 we got the bond order of 2, and for the O2 negative we got the bond order of 1.5. In the previous lecture I have told you that higher the bond order, higher will be the stability of that molecule. So that means O2 positive is most stable and O2 with a negative charge is the least stable because of the least bond order in case of O2 negative. So that's all for today. I hope you understood today's lecture. In this lecture, we have evaluated the bond order, and for O2 we got it to be 2. For O2 1 negative, we got it to be 1.5, and O2 1 positive, we got it to be 2.5. That means O2 positive will be more stable than O2, which will be more stable than O2 1 negative. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.